Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be looking at second-order derivatives, d2y by dx squared. But first of all, a few reminders. If we differentiate y with respect to x, we get dy by dx. And dy by dx gives us the gradient of the curve of a function. But in more general terms, what dy by dx gives us is the rate of change of y with respect to x. That's the rate at which y changes as x changes. So for example, if dy by dx equals 2, what that means is that y increases by 2 for every one that x increases. If we differentiate dy by dx with respect to x, we get the second differential, d2y by dx squared. But what exactly is that? Well, d2y by dx squared gives us the rate of change of dy by dx with respect to x, the rate of change of the gradient. This is the rate at which dy by dx changes as x changes. So for example, if d2y by dx squared equals 2, what that means is that the gradient, dy by dx, that will increase by 2 for every one that x increases. d2y by dx squared, it's sometimes called the second differential of x, it's sometimes called the second order derivative, and sometimes it's just called the second derivative. Keep an eye out for any of those phrases. They all mean d2y by dx squared. In function language, what we would write is that the first derivative, dy by dx, that equals f dashed of x. The second derivative, d2y by dx squared, that is equal to f double dashed of x. Okay, let's have a look at a few examples. So given that y is that complicated looking function, find dy by dx and then differentiate your answer to get d2y by dx squared. As complicated as this looks, you just treat it one term at a time. And the first thing you need to do is rewrite these two terms in the middle into the form a times by x to the n, some number times by x to some power. And then you can just use the normal rule to differentiate them. Okay, have a go at working your way through all of that. Pause the video and come back to me again when you're ready. Okay, let's have a look. So as we said, the first thing that you need to do is rewrite this into the form where we can differentiate it. So all of these need to be written as some number times by x to a power. 3 root x is 3x to the half. 5 over x squared is 5x to the minus 2. Then we can use the normal rule. Multiply the power, and then the power goes down by 1. So 3 times 4 will give me 12, and the power will go down to x squared. A half times 3 is 3 over 2. The power goes down by 1 to minus a half. Minus 2 times by the 5 gives me minus 10. The power goes down to minus 3. When I differentiate a constant times by x, I just get the constant, so I just get 8. And when I differentiate a constant on its own, it vanishes altogether. I get 0. Now that is the answer, but I could tidy it up, and it's certainly important that you're able to do so. This term here is probably the most complicated one. The 3 over 2, the 3 stays on the top of the fraction, the 2 stays on the bottom. Minus means we've got the reciprocal of x, and half means we've got the square root of x. And then minus 10x to the minus 3 is just minus 10 over x cubed. We were then asked to differentiate it a second time to find the second differential. Now the most convenient form to use is this one, where I've just got a number times by x to a power. So that's dy by dx. If I differentiate that with respect to x, then I'll get d2y by dx squared. 2 times the 12 gives me 24, minus a half times by the 3 over 2 gives me that, minus 3 times by the minus 10 is plus 30, and when I differentiate the constant, it goes completely. Again, that is the answer, but if I was going to tidy it up, it's this middle term, which is the most confusing of them, and you get the 3 on the top, the 4 on the bottom. The minus means that you've got the reciprocal of x. 3 over 2, the 3 means cubed, the 2 means square root. So I'll have the square root of x cubed. And then 30x to the minus 4 is 30 divided by x to the 4. Okay, example 2. This time using function language. Given that f of x is equal to 3 divided by 5x to the power of 4, find the second differential, f double dashed of x. Have a go at this yourself, pause the video, and come back to me when you're ready. Okay, as with the last question, the first thing we need to do is rewrite the question. If we've got 3 over 5x to the 4, that is the same thing as 3/5 times by x to the power of minus 4. If I differentiate that once, then I'll get minus 4 times by the 3/5, which gives me minus 12 over 5. The power goes down by 1. Minus 4 take away 1 is minus 5. That's the first differential. To get the second differential, I just differentiate it again. So minus 5 times by minus 12 over 5 gives me 60 over 5. The power goes down by 1 to minus 6. 60 divided by 5 is 12. So that is 12x to the power of minus 6. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 166 and have a go at exercise 8G. Thank you very much for listening, and cheerio.